To see how trigonometric functions were first found, let's look at how pi is seen with circles. Let's observe the circle which has a diameter of 4 centimeters. The circumference of this circle is 12,566 centimeters. Now to measure a circle's circumference, which is a distance around the outside of the circle, and divide it by its diameter, for this circle we get that 12,566 divided by 4 is equal to 3,141, and so on. Let's do this again for a different circle. Let's take a circle which has 6 centimeters diameter. The circumference of this circle is going to be 18,85 centimeters. Now we get that 18,85 divided by 6 is equal to 3,141. Let's do the same again for this circle. We're going to take a smaller circle which has a diameter of 2 centimeters. The circumference of this circle is going to be 6,283 centimeters. 6,283 divided by 2 is equal to 3,141. And this would be true for every circle in the universe. Let's take a circle of the unknown diameter, and it has some circumference. If we take this circumference and we divide it by the diameter of this circle, we are always going to get the constant 3,141 and so on. This number that we always get is called pi, and that is how we came up with the formula to work out the circumference of a circle. Basically, the circumference of any circle is pi times its diameter. It turns out we can do something similar with right-angled triangles. Now let's take a look at a right-angled triangle. This is the right angle of this triangle, and let's say that this angle has 60 degrees. This side has a length of 1 and this side has a length of 2. Well, that means that this other side has the length of 1,732. We are going to label the sides for a reference. I'm going to call this side H for hypotenuse. It is the longest side of a triangle. This side I'm going to call O because it is the opposite side of the angle of 60 degrees. And the remaining side I'm going to call A because it's adjacent to the angle. If we take the opposite side and divide it by the hypotenuse, basically we are taking O and divided it by H. That is going to give us 1.732 divided by 2, and that is going to be equal to 0,866. This number, 0,866, is interesting because it is going to appear again and again for all the right-angled triangles, for a fraction of opposite side over a hypotenuse. Let's observe the next triangle. This is again going to be a right-angled triangle. It is going to have the sides of the length of 3 and 6, and the remaining side is going to have the length of 5,196. Let's label the sides as before. This is the angle of 60 degrees, this is the adjacent side, this is the hypotenuse, and this is the opposite side. If we look again at the opposite side divided by a hypotenuse, we are going to get 5,196 divided by 6. And that is going to be equal to 0,866. So it's a different triangle with the same answer. Now let's look at this triangle. Again, we have a 60-degree angle, and we have the sides of the length 0.75, 1.5, and 1.299. Sides are adjacent, hypotenuse, and opposite. Now doing the same thing again opposite over hypotenuse, we get 1.299 divided by 1.5, which is equal to 0.866. So we get 0.866 again. So for all right-angled triangles with a 60-degree angle, if you take the opposite side and divide it by hypotenuse, you will always get 0.866. The number which was discovered in this manner is called a sinus of 60 degrees. Now at this point we can make the following statement. A right-angled triangle with another angle of 60 degrees will always have the opposite side divided by the hypotenuse equal to 0.866. This statement can be used to find a missing side when one of them is missing. Example: we have a right-angled triangle. The longest side of that triangle has the length of 5. And the side labeled X is missing. We have a 60-degree angle right here, and this is a right-angled triangle. So if we label the sides as before, so a hypotenuse and an opposite side, we know that opposite side divided by the hypotenuse is equal to 0.866. And when we plug in the values from the example, we get that x divided by 5 is equal to 0.866. Well, at this point, it is obvious that x is equal to 5 times 0.866, and that means that x is equal to 4.33. Now let's keep a record of this calculation in a table. In one column, we're going to keep the record of degrees of the other angle. So we have the angle of 60 degrees. And the fraction O divided by H, opposite side divided by hypotenuse, for 60-degree angle, we get that it is equal to 0.866. Keeping a record of these calculations is going to make future calculations of the type finding an unknown length of one side of the right angle triangle, where one side is known and the angle different from the right angle triangle is known easier. Another helpful tool are graphs. So let's plot the result on the graph, because that is going to help us notice patterns. So on this graph, on the x-axis, we are going to put the sizes of the angles. So this is going to be 0, then 30 degrees, 60 degrees, and finally 90 degrees. And on the y-axis, we are going to keep the record of the fraction of the opposite side divided by the hypotenuse. For a 60-degree angle, we had that fraction opposite side divided by the hypotenuse is 0.866. And let's say that that dot is right here. All the right-angled triangles that we had up to this point had another angle of 60 degrees. Other angle in a right-angled triangle won't always be 60 degrees. Let's take another look at a right-angled triangle which we already had. A hypotenuse is the length of 2, this is the right angle, adjacent side is 1, and the opposite side is 1,732. This is the angle of 60 degrees. In this triangle, the other angle is going to be 30 degrees. Sum of all the angles in a triangle in Euclidean geometry is equal to 180 degrees. In this case, the opposite side is opposite of a 30 degrees angle. So this is going to be the opposite side. This is going to be a hypotenuse, and this is going to be the adjacent side. Now let's do the calculation. Opposite side divided by the hypotenuse is going to be equal to 1 divided by 2, which is 0,5. This will always be the same for all the other right-angled triangles with a 30 degrees angle. If we take a look at this triangle, Of course, it is a right-angled triangle. It has the sides of the length of 3, 6, and 5,196. And this is the angle of 30 degrees. We are again going to get that opposite side divided by the hypotenuse is equal to 3 divided by 6, which is 0,5. If we take a look at this right-angled triangle, this is the right angle, and the angle of 30 degrees is right here. We have the length of the opposite side to be 0.75. We have the length of hypotenuse to be 1.5, and we have the length of the adjacent side to be 1.299. The fraction opposite side divided by the hypotenuse is going to be 0.75 divided by 1.5, which is again going to give us 0,5. So let's add this result in our table. For a 30-degree angle, we get 0.5. And now let's add this result in our graph. Let's say that 1 is here and 1/2 of, or 0.5, is going to be right here. Now let's get back to our previous statement. A right-angled triangle with another angle of 60 degrees will always have the opposite side divided by the hypotenuse equal to 0,866. This entire statement can be said by one simple expression, and that is sine of 60 degrees angle is equal to 0,866,025,40378, and so on. In our second case, we took a look at a right-angled triangle which had an angle of 30 degrees. Sine of 30 degrees was equal to 1/2 or 0.5. Now, the complete table of all the angles of integer degrees from 1 degree all the way up to 89 degrees has already been made. And here is what it looks like. And in this table you can see the previous result which we got. The value of 0,866, which corresponds to the angle of 60 degrees, or the value of 0,5, which corresponds to the angle of 30 degrees. And the graph which we had started plotting, if you do it for all the angles from 0 degrees to 90 degrees, you get the curve which we call the sine wave. Now let's talk about cosine and tan. Let's observe the first triangle which we had worked with. That was a right-angled triangle with a 60-degree angle, and it had the sides of the length of 1 and 2 and the 0 and 1,732. This was the hypotenuse, this was the adjacent side, and this was the opposite side. What we did was that we had divided opposite side by the hypotenuse. Just as easily we could have looked at the fraction in which we had divided the adjacent side by the hypotenuse instead. In that case, we always get 0,5. This value 0,5 is the cosine of 60 degrees. Now, if we do the same thing again, just look at the opposite side divided by the adjacent side, we are going to get that opposite divided by the adjacent is equal to 1,732 divided by 1, which is equal to 1,732. And that is tangent of 60 degrees. These formulas which we use in trigonometry are as follows. We have a right-angled triangle with a right angle with an angle alpha. This is the hypotenuse. We have the opposite side, and we have the adjacent side. Sine alpha is equal to the opposite side divided by the hypotenuse. Cosine of alpha is equal to adjacent side divided by the hypotenuse, and tan of alpha is equal to the opposite side divided by the adjacent side. And we often use them to find the missing angles or sides. We often use the SOHCAHTOA trick to remember them. S-O-H, so, ka, toa. SOHCAHTOA means sine, opposite side, hypotenuse. Opposite side, hypotenuse. Kah means cosine, adjacent side on the top and hypotenuse on the bottom of the fraction. And toa means tangents, opposite side and adjacent side on the bottom. In this video, I have shown you a very basic observation of where the sine, cosine and tan function come from. You can take the values of angles like 270 degrees or negative 315 degrees. Sine of 270 degrees is going to be equal to negative 1, and cosine of negative 315 degrees is going to be 0,707, and so on. These angles are not going to work inside of a right-angled triangle. In the next video, I will elaborate further on these ideas, and I will introduce a formal way of defining these trigonometrical identities using the unit circle. Thank you for watching. I hope that you have found this video to be useful, and if that is the case, please subscribe to the channel. I'm looking forward to reading your comments.